If your students are struggling with negative numbers, Switch is a fast-paced card game that replaces standard worksheets with a competitive challenge. In under 6 minutes, you will learn the deck setup, the turn mechanics, and the strategy needed to win. Before dealing, you need to remove all face cards, the jacks, queens, and kings, from a standard deck. Leave the aces in the deck. For this game, every ace has a mathematical value of 1. By making this quick modification, you turn a household deck of cards into a practical tool for comparing and ordering integers. The primary rule of Switch is straightforward. The color of the card dictates whether its number is positive or negative. Red cards represent negative integers. For instance, the 3 of hearts counts as -3. Black cards represent positive integers, meaning the 9 of spades counts as positive 9. To begin, shuffle the deck and deal exactly 6 cards to each player. Place them face up in a horizontal row from left to right. Here is the critical constraint. Players cannot rearrange the initial order of these 6 cards. Take the remaining cards and place them face down in the center of the table. This becomes your draw pile. Because the cards are locked in their dealt position, players have to evaluate each spot in their row and decide how it fits onto a personal number line. To win the game, a player must be the first to sequence all 6 of their cards in order from least to greatest, reading left to right. When evaluating their sequence, players often misjudge negative values. Visualizing a number line helps clarify that -6 sits further left, making it less than -2. A turn begins with the player drawing the top card from either the draw pile or the discard pile. The player then looks at their row and decides if this new card helps build a continuous least to greatest sequence. If it does, they swap the drawn card with any existing card in their row. The replaced card goes face up onto the discard pile. If the drawn card does not improve their current sequence, they simply place it directly on the discard pile. With every draw and discard, players have to explain their reasoning out loud, which naturally builds mathematical discourse into the gameplay. Let's look at a late game scenario where a player is exactly 1 correct card away from finishing their sequence. This diagram shows an example game sequence. The top row of cards displays the integers -6, -3, +8, +5, +6, and +10. The anomaly here is the +8. It breaks the sequence because it is greater than the +5 and +6 that follow it. To achieve a winning order, the player needs to find a card valued between -3 and +5 to take the place of that 8. On their turn, the player draws the ace of diamonds. Since red cards are negative and aces equal 1, this counts as a -1, which perfectly fits the required range. The player executes the swap, replacing the sequence-breaking +8 with the newly drawn -1. This completes the row. The cards now set in the correct least to greatest order: -6, -3, -1, +5, +6, and +10. Executing this final swap proves the player can compare and correctly position integers along a number line. Once a player calls out their correctly ordered sequence, they win the round. When your students master the base game, you can introduce a new rule. Require the final sequence to contain exactly 3 red negative cards and 3 black positive cards. You can also allow players to trade cards with their opponents, adding a layer of risk as they weigh the benefits against helping an opponent win. Grab a deck of cards, set up these variations, and watch your students learn to order integers through active play. Because students have to evaluate and justify every move, Switch helps them visualize how negative and positive values relate on a number line.